Welcome to today's presentation on Parker Hannifin's MPP servo motor. The MPP is Parker Electromechanical North America's flagship servo motor and was designed and is manufactured in our 78,000 square foot facility located in New Ulm, Minnesota. The MPP motor line is available in 6 frame sizes ranging from 92 all the way up to 270 millimeter. Torques range from 1.5 all the way up to 500 Newton meter. Segmented lamination technology is used to maximize copper fill and power density of the motor. The motor has a very low inertia with a large bandwidth, meaning that the motor is capable of very high acceleration rates. And all the MPP motors are fully customizable to meet any unique application requirement. Our manufacturing facility is state-of-the-art. Top-of-the-line CNC equipment is used to machine all of the primary motor components. We will now show you some of the key steps in the manufacture of an MPP servo motor. Here our motor technician takes the individual lamination segments and loads them into what we call our cradle assembly. This assembly holds the segments in place for installation onto our automated winder. At the winding station, the technician loads the cradle assembly onto the winder. Each segment is now wound with a particular gauge of wire with a particular number of turns. Having this programmed into the system ensures that the motor will perform as specified in our Parker catalog. You can also see how easy it is for us to program and manufacture custom windings for various application requirements. After the segments are complete, the technician removes them from the cradle assembly and mounts them to the stator fixture. The 3 segments shown here represent one phase of the motor. An additional 2 phases will be added to complete the 3-phase stator. The stator now moves on to where it is assembled into its motor housing. The housing is heated to expand its inner diameter. When ready, it is loaded onto an assembly fixture, and the housing is then pressed over the stator. The assembly is then cooled to secure the stator into the housing. This process is called heat shrinking. All MPP stators are encapsulated in the motor housing with a 2-part epoxy. This process, called potting, provides additional protection and helps to draw heat away from the motor stator. In another area of the factory, a technician works on the motor shaft assembly. Here we see how the motor magnets are precisely assembled to the shaft, creating the motor's rotor. The magnets are held in place, allowing the epoxy to begin setting. In a few moments, the assembly can be handled and cleaned by the technician, and then will be placed in an oven for additional curing time. When ready, the rotor assembly then moves on to the roving station. All MPP rotors are wrapped in Kevlar. The Kevlar wrap provides additional holding force for high-speed applications. It also creates a barrier to protect the rotor when exposed to harsh environments. With the major components completed, final assembly of the motor can begin. Here an automated press assembles the shaft and rear plate to the motor's main housing. The motor is then transferred to an assembly tray. Remaining parts such as motor labels, encoders, and connectors are kitted on the tray so that they are within easy reach for the assembly technician. This process also supports the assembly of customs by isolating the motor with any unique components. Trays move down the line one at a time. Components are assembled to the motor and then move down the same line to begin their functional tests. At the test station, encoders are aligned, inductance and resistance is confirmed, and the motor is spun at rated speeds to confirm that it is operating to specification. Upon successful completion of its functional test, the motor receives final preparation and is ready to ship. Thanks for visiting with us today. Go to parkermotion.com for more information on the MPP servo motor, as well as other motion control products offered by Parker Hannifin.